In this video, we will be solving equations that have fractions. So let's start off with equations that just have one fraction. In our first example, we have 6 equals 8 plus x over 3. Now this is pretty straightforward. We're just dividing by 3. And since we're dividing by 3 here, we have to multiply by 3 and do this on both sides. Multiplying is the opposite operation. So that gives us 3 times 6, and this equals 3 times 8 plus x over 3. So of course these 3's cancel out, and we're left with 18 equals 8 plus x. So x is going to equal 18 minus 8, and you have to do that on both sides. So it's 18 minus 8 equals 8 minus 8 plus x. And x equals 18 minus 8, which is 10. Our next example is 3/4 times y minus 5 equals 7. Now this example is a bit different from our first one because here we're just dividing by 3, and this is the same thing as saying 1/3. 1/3 is the same as dividing by 3 because we know that 8 plus x times 1 is 8 plus x, and then we're just dividing by 3. But in this example, we have 3/4 and we're actually writing out our fractions. And when we write out a single fraction in our equation, what we have to do is multiply each side by our denominator. So again, we have to multiply each side by the denominator of this fraction. So if we write this out, we get 3/4 times y minus 5. And this will be multiplied by 4. And this equals 7 multiplied by 4. Now, if you look closely, you will understand the reason why you have to multiply by our denominators. 4 is the 4, and we have two 4's here. So by multiplying by our denominator 4, these 4's will cancel out, just like this 3 and 3 here. So since these 4's cancel out, we can continue to multiply expand this bracket here and simplify this here and continue balancing our equation. So we get 3 times y minus 5 equals 28, because that's 7 times 4. So 3y minus 5 is 3y minus 15, and that equals 28. So if we continue this here, 3y minus 15, so we have minus negative 15 here, and we have to add 15, do the opposite operation. So 3y minus 15 plus 15 equals 28 plus 15. So 3y equals 43. So that's 28 plus 15. And y equals, so first, before we do that, we have to divide each side by 3. So 3y divided by 3 equals 43 divided by 3, and y therefore equals 43 divided by 3. So to sum this all up, when we have one fraction like we're dividing by a number, it's just the same as saying 1 over that number. So this was like saying 1 divided by 3, or 1/3 times 8 plus x. And when we're solving this equation, we have to multiply each side by the denominator of this of the fraction here, and that's how we got 10 here. And in this example where we have 3/4, even though we're actually writing out our fraction, we're still multiplying our denominator so we can cancel out our numbers and continue solving our equation. So in this example, we'll be dealing with two fractions. So we have x minus 5 divided by 2 here, and this equals x minus 7 divided by 5. So in our last example where we had one fraction, we multiply each side by our denominator. But here we have two denominators, so let's just pick one and try that. Let's say we multiply each side by 2. So that's 2 times x minus 5 divided by 2. And this equals x minus 7 divided by 5 times 2. So if we try to work this out, these two 2's will cancel out. So we get x minus 5. They'll cancel out. But on this side of our equation, on the right side, we are left with 2 divided by 5. We still have that fraction. So what number do you think we could use to multiply each side by so that we don't have to deal with our fractions? Well, to do this, we just take the lowest common multiple of both sides. So if we write out our multiples of 2 and 5, of 5, we get 5, and we have 10 and 15. So let's keep it to that. And here we have 2, 4, 6, 8, 10. So as you can see, the lowest common multiple is 10. Because we know that 5 times 2 is 10 and 2 times 5 is 10. So we can multiply each side by 10. So if we do that, we get 10 times x minus 5 divided by 2, and that equals 10 times x minus 7 divided by 5. So now that we've done that, as you can see, we can just divide 10 and 2, so that gives us 5 times x minus 5. And it's the same thing here. We can just divide 10 and this 5. So that gives us 2 times x minus 7. And the reason we can do this, we can divide our 10 by 5, is because we're multiplying our two terms on our numerator. So it's like saying 10 times x minus 7 divided by 5. And since we're multiplying, just one term can be divided by 5. So of course it'd be easier to divide 5 by 10. We could just divide 10 and 5 and get 2. So it's 2 times x minus 7. And we could not do this. We could not divide by 5 if we are adding 10 and x minus 7. We'd still end up with a fraction because we could divide 10 and 5, but we'd also have to divide x minus 7 and 5 because we're adding. And the same thing is if we're subtracting. Only if we're multiplying, like here, can we divide by 2 and 5 and end up with our whole numbers and get rid of the fractions. So now that we've dealt with our fractions, we've got rid of them, it's pretty straightforward. We can use our distributive property and solve this equation. So here we have 5 times x minus 5. So it's 5x minus 25. And this equals 2 times x minus 7. So that's 2x minus 14. So then we have our like terms, we can collect them. So it's 5x minus 25 equals 2x minus 14, 5x and 2x and negative 25 and negative 14. So it's 5x, and we could subtract 2x from both sides. So it's 2x and minus 25. And that equals 2x minus 2x and minus 14. So the 2x cancels out, and we're left with 3x minus 25 equals negative 14. And this, of course, we can use our opposite operation with negative 25. Since we're subtracting, we can add. So it's 3x minus 25 plus 25 equals negative 14 plus 25. 3x therefore equals 25 minus 14, or negative 14 plus 25, and that is 11. So x equals 11 over 3. So in this example, we have 1/3 times 2x minus 5, and this equals 3 over 4 times x minus 2. So in this example, we have our two denominators of our fraction. We have 3 and 4. So we have to take the lowest common multiple, and our multiples of 4 would be 4, 8, and 12. Of 3, it's 3, 6, 9, 12, 15, 18. But as you can see, 12 is our lowest common multiple. So we have to multiply each side by 12, and we can get rid of our fractions. So if we do that, we get 12 times 1/3 times 2x minus 5. And this equals 12 times 3 over 4 times x plus 2, sorry, x minus 2. And now that we're multiplying 12 and 1/3 and 12 and 3/4, so 12 times 1/3 is 4. It's like saying 12 divided by 3, which is 4, times 2x minus 5. And here 12 times 3/4 is like saying 12 times 3, which is 36, divided by 4, which is 9. So it's 9 times x minus 2. And now we can use the distributive property. So it's 4 times 2x, which is 8x, minus 20, which equals 9 times x, which is 9x, minus 18. So we can move our 8x to our right side. So it's 8x minus x minus 20 equals 9x minus 8x minus 18. So this becomes x minus 18 and that equals negative 20. So this negative 18 can be moved to our left side. So now we get negative 20 plus 18 and that equals x plus 18 minus 18 and negative 2 equals x. X equals negative 2. So our final example has two fractions on our left side of the equation. So in this example we have 3x divided by 7 minus 4x plus 3 divided by 3, and this is going to be equal to 4. So in this example, we have our two denominators, 7 and 3, and this works the same way as if the fractions are on different sides. We're just going to be taking our lowest common multiple and multiplying that by each side. So our lowest common multiple will be 21. 7 times 7 times 7 is 21, and 3 times 7 is 21. So that gives us 21 times 3x minus 7 minus 4x plus 3 divided by 3, and that equals 4 times 21. So as you can see here in our brackets we have our two fractions and we have a number outside our brackets. So in this situation we have to use our distributive property and multiply the 21 by each fraction. So first we have 21 and this will be multiplied by 3x divided by 7. So we know that this is the same as 21 divided by 7, and that is 3 times 3x, because 21 divided by 7 is 3, and this is here is 21 times 4x plus 3 divided by 3, so that's 21 divided by 3, which is 7, and this will be multiplied by 4x plus 3, which is equal to 4 times 21, which is 84. So now we can use the distributive property to expand this and continue to solve our equation. So 3 times 3x is 9x. And we have negative 7 times 4x plus 3, which is negative 28x, because that's negative 4x times negative 7, and negative 7 times positive 3 is negative 21. And that gives us 84. So now we can simplify this, so we get 9x minus 28x, and that's equal to negative 19x minus 21, which equals 84. So we can get rid of our negative 21 by using our opposite operation, addition, and adding that to this side here, our right side. So that's negative 19x minus 21 plus 21, which equals 84 plus 21. So negative 19x equals 105. And x equals negative 19 divided on both sides. So we're dividing by negative 19 here. and we'll also divide by negative 19 here. So x equals negative 105 divided by 19. So that's it for today's video. I hope you now understand how to solve equations with fractions, and this is the hardest type of equation that we will be solving in this unit. And that means in our next video we will be moving on to word problems, so stay tuned for then, and if you have any questions, please leave them in the comment section below. Thank you.